the co-host.
Yun, okay po. Okay na po.
All right. So as far as matrix operations are concerned, you're already familiar with well, matrix addition, matrix subtraction, even matrix multiplication, right?
Opo.
And then even taking the transpose of a matrix.
Opo.
Baka meron po kayong mas magandang method?
As far as matrix I think as far as computations are concerned, okay na siya. Pero kasi nung approach ko typically is ano nung we unearth the theory. So how about ito? I'll just try to ask some questions. So halimbawa, Joshua, if you look at matrix A and B, of course we know that if you have two matrices, it doesn't mean you can always multiply them. Diba? Kasi for
Opo.
example, A is 4 by 7 and B is 7 by 11, then you can multiply AB, right? But
Opo.
not BA. Kasi this will be 7 by 11 and A will be 4 by 7. So AB, this can be done, right?
Opo.
But BA can't be multiplied because these two matrices, B and A, are incompatible. So even the very act of multiplication is different from what we do with numbers. Kasi 2 times 3 equals 6 is same as 3 times 2. But with matrices, even if you can do A times B, it doesn't mean you can do B times A. And even if you can do both, it doesn't mean that the results are going to be the same. After all, if A is 4 by 7 and B is 7 by 4, then that would mean that AB will be 4 by 4. On
Tapos
the
yung
other
isa po,
hand,
7 by 7.
yeah, no, BA is going to be 7 by 7. So claro that AB and BA are not going to be equal. But even if kailan ba nung AB and BA magkakapareho ng size, let's say when A and B are n by n and B is n by n, so mangyayari AB and BA are both n by n. So there's a possibility that they're equal, but it doesn't mean that they're going to be equal. Pwede pa rin magkaiba. So many of the things we assume is true for multiplication of real numbers cannot be assumed to be true when we're talking about multiplication of matrices. But I'd just like to write down for the record, ano nung nitty-gritty ng definition of matrix nung formula. So suppose the matrix A has entries A sub ij. Suppose this is an M by P matrix, and B given by B sub ij is a P by M matrix. So are you familiar with this way of denoting matrices? So A sub ij is a generic term, and then I represents the row. Okay, I represents the row of the matrix, and J represents the column, which means
Opo.
that
Opo.
okay.
Yung, yung tanong ko nga po dyan, parang bakit sila palabas silang, pwede po maglagay ba po ng comma or something to separate them?
Nung paglalagay ng comma, kasi mangyayari, in many proofs kasi, kunwari, you're looking at the entry in row 23 and then column 37. Then it's better to represent that as A sub 23 comma 37, because otherwise it will be confusing if you're just going to write down right after each other 2337. But when it comes to proofs, writing down a comma each and every time ends up being tedious, because when you look at A sub ij, we're able to distinguish between I and J easily. which makes a comma unnecessary. So
Mm.
in proofs, when you're referring to the general entry, A sub ij will suffice.
Sa general lang po.
Sa general lang. Oh. So in general naman sa mathematics, if there is a specific notation that's prescribed, but when you try to follow it in special circumstances and you realize, oh hey, this is gonna be ambiguous, then the burden is on us to make sure we are able to communicate properly. Alam natin magiging magulo pala or ma-misinterpret, then the onus is on us to ensure that mabawasan natin ng confusion. Okay.
Opo.
Ayun yung mga ano yun, yung mga nakikita mo sa mga Facebook, yung mga ano yun, yung mga 7, ano yun, yung mga divided by 3, no, mga ano, nung mga nag-aaway-away ng mga tao tungkol sa MTAS. And I'm like, pwede ba ayusin niyo na lang nung ano, lagyan niyo na lang ng parenthesis nung ano nung sa simula. So, I understand ng mga memes na yon are meant just to get a rise out of people para mag-usap-usap sila. But I wouldn't really call those expressions um, representative of math problems. Okay, hindi talaga sila math problem. Mga ano sila, mga para lang mag-away-away ang mga tao. Okay. So anyway, ano ng definition ng product? Okay. Then the product of A and B denoted by AB as usual is the M by N matrix C. So if the general entry is C sub ij, so then the definition requires specifying what is the entry in row I and column J of matrix C. So the idea is we do it like this: C sub ij. So we have matrix A, and then we have matrix B. These look like square matrices, okay? Pero just for convenience, let me make it look like a square matrix. So if this is C sub I J, di ba what we want is we want to extract the entries in row I, and in B, we want the entries in column J.
Opo.
Okay. And then we're going to multiply corresponding entries. In matrix A, the entries in row I are A sub I1, and then you have A sub I2, and then, oops, let me provide more space, and then A sub I3, then plus dot dot dot, until we get to A sub I, and then because A is M by P, row I has P entries, so A sub IP. And then on the other hand, for column J of B, so column J, so that means we're gonna write down B entries where the second subscript is J. So 1J, B sub 2J, B sub 3J, and then B was specified to be a P by N matrix. In other words, B column J of B has P entries. So this goes all the way to rather B sub PJ. We'll observe that in this particular summation, the specific I here appears here, okay? Because, well, it's row I of column of matrix A. And then the J is this subscript, okay? Column J of matrix B. And if you look at the terms in the sum, So naturally, you see I and J there, but they vary in a particular subscript, which runs from 1 and then 2 and then 3 all the way to P. And so we can write this in summation notation in the following manner. You have A sub I, and then B sub, second subscript is J, and then the underlined in purple, if we call it K, so underlined in purple, okay, K, K changes from 1, 2, 3, all the way to P. K from 1 all the way to P. So C sub ij. Okay. So again, I just wanted this for the record written down. I know that you've had some experience with multiplying, but let's say there is a certain property that we want to justify and involves multiplication of matrices, then that means we're gonna have to refer to this particular formula.
Opo.
Okay. So a theorem about multiplication of matrices. Suppose A, B, and C are matrices of the appropriate sizes for the indicated multiplication. In other words, I'll be writing down some multiplication statements. Assume that the sizes are compatible. Okay, number 1, A multiplied to BC is equal to AB multiplied to C. In other words, while matrix multiplication may not be commutative, it is at least associative. As long as if you go from left to right, it's A on the left, B is on the right of A, and C is on the right of C. As long as you don't change how they're written from left to right. But which two matrices you decide to multiply first is not going to make any impact. Okay, and then number 2, fortunately, we still have the distributive property A plus B multiplied to C is equal to AC plus BC. Are these properties you have seen before, Joshua?
So did this po carry on to vectors po kasi vectors are one by or
Yes,
one
yes,
and
yes. These apply to vectors. If by vectors you're referring to, let's say, column vectors and row vectors.
opo.
Okay.
Nakita ko na ano ko lang po na hindi commutative pero I don't know kung meron ba the others apply. So yung distributive, ay di, sa the vectors po alam ko na po yung mga kumbaga is associative and distributive pero I do not know sa kung matrices ba distributive ba po or something.
So ito actually just to be able to justify why I will not do it for all of these 4 properties. Well, how does one justify a property like 1 or 2 or 3 or 4? It will be by using the definition that we have provided above. So let's try it for let's say number 2. Okay? Tapos if you're interested, you could choose one of the 3 other statements, and I could write down a proof if you're interested. So ito, proof of number 2. So as usual, let A, which is A sub ij, and B, which is B sub ij, we need to be able to add A and B so they should have the same size. So let these be M by P. And C, the matrix C sub ij, let this be P by M. Okay. So A plus B is going to be M by P, and then C is P by N. So oh yeah, the final and after you carry out the multiplication, either on the left side of 2 or the right side of 2, you should get an M by N matrix. So let's start with the left side of number 2. Left hand side, A plus B multiplied to C. But then we know that when you add a matrix, uh, when you add a matrix, you're just adding term by term. So the entry in row I column J will be A sub ij plus B sub ij. That's in A plus B. So now when you do the multiplication of A plus B with C, we write it down as a summation K running from, well, from A plus B, you have A sub, so ba mangyari, ito, let's say A plus B is the matrix S. That's the sum. So S sub ij. If you, so instead of A sub ik here, we would have S sub ik. Okay. So again, this would be okay. If S is equal to S sub ij, which is defined as A plus B, so ito nung S sub ij. So A plus B is the sum. So we have S sub, oh, hold on. Left hand side, A plus B. Sorry, let me decide to do it this way. Okay. Okay. For number 2, okay, sorry, let me do this again. Observe that um, let's call it U. U, which is A plus B, C, and V, which is AC plus BC, are both M by N matrices. So we just need to compare corresponding entries. So we will show, what we want to do is to show that U sub ij is equal to V sub ij, whatever the indices I and j are, where I runs from 1 to M and J runs from 1 all the way to M. So at least it's clear that nung V wala siyang extra entries that does not correspond to anything in U and vice versa. Okay, so let's start with U sub ij. I realize kasi that if you're gonna use the definition, and this is the primary equation, what this is telling us is the particular entry in row I, column J. So kaya napatigil ako and decided, oops, I should work with comparing U sub ij and V sub ij. Okay, so this would be the sum as K runs from 1 all the way to P. So nung U kasi is S times C. Okay, S, C. So S sub I, K, and then C sub K, J. Okay, but S sub I, K is A sub I, K plus B sub I, K multiplied to C sub K, J. Ito using S sub ij is A sub ij plus B sub ij. And then, well, if you look at what we've written down, it's just real numbers. Ito mga A sub ik, B sub ik, and C sub kj, these are just numbers. So I can rewrite this as sum k running from 1 to P, A sub ik, C sub kj. And then, nung sum, we can break that down into two summations. k from 1 to p, and then b sub ik, and then c sub kj. Okay, where we notice that the first summation corresponds to the ij entry in matrix AC.
Hmm.
So this is the ij entry in matrix AC, and this, on the other hand, is the ij entry in matrix BC. So therefore, if you add them together, you would have the ij entry in AC plus BC, but in other words, that's B sub ij. Okay,
Bro, nice.
so that's it. Therefore, yes, we do have the distributive property applicable for number 2. Okay. Okay ka na dito, or would you like to see, say, paano kaya nung sa 1, 3, and 4? Paano isusulat nung proof? Or okay na?
Okay na po siguro. Yung ano po, yung 4 po, parang na-prove na po natin. Tapos yung 1,
Mhm.
na-prove na rin po.
Okay. So nung number 4, so when you do a transpose, so babalik na rin lang yun. It's B transpose and then C transpose. Okay. So some remarks about matrix multiplication. Okay. Number 1, AB and BA are not necessarily equal, even if they are both defined and have the same size. And then number 2, even if AB is equal to 0. By this we mean the zero matrix. When you talk about the zero matrix, it's not just a single matrix because, well, when we describe a matrix as a zero matrix, it means that all the entries are 0. But then you can have a 4x5 zero matrix or 3x7 zero matrix. Okay, but even if the product is 0, does it mean that one of the matrices A or B is a zero matrix?
Hindi po.
No. All right, you're correct. It is possible that A is not the zero matrix and B, so it's possible that none of A or B is the zero matrix. Okay. But of course, if A is 4x7, I'm referring to comparing it with the zero matrix of size 4x7. Okay, and if B is size 7x11, on the other side, I'm referring to the 7x11 zero matrix. And one more thing. Okay, even if the product AB is equal to AC, does it follow that B and C are the same matrix?
Hindi po kasi parang pwede naman may imposter columns po sa isang matrix na that parang they will give the same result. So,
Yes.
pwede po sila mag-iba rin.
Okay, so that is definitely correct. Okay. Now, the n by n identity matrix is typically denoted by I sub n. And what this is the n by n matrix where all the diagonal entries are 1 and everything else is 0. You've seen this before, yes?
So, yung ano nga po, yung identity abo. Yung,
Alright.
so, one lang po yung main diagonal.
Okay, and you're already familiar with invertible matrices or non-singular matrices.
Yung mga, alam ko pa yung distinction kung ano, kung invertible ba sila or not.
Okay. All right. So, okay. One thing we know about the identity matrix is that for any M by N matrix A, if you multiply A by I sub N, so this makes sense now because A is M by N and I sub N is N by N. So the result will be what matrix?
Yung ano pa rin po, si A pa rin.
A. And also, so here what I did is, no matrix A is post multiplied by I sub n. Here, what I want to do is I want to pre-multiply A. But because A is M by N, then we should choose the M by M identity matrix. This is also going to be A. Okay. So if you write down the multiplication, it all falls into place. Okay. But let's just say let's indulge ourselves and try to prove let's say the first one. Proof of A I sub n is equal to A. Okay. Let's say C be A sub I sub n. So we will show what we want to do is to show that C sub ij, the claim is to show that A sub im on the left is equal to matrix A on the right side. So we wish to show that C sub ij is equal to A sub ij.
Saka as a result pala po, kung ganyan, is it possible po to parang inverse proof na you find the mystery identity the mystery matrix that when any matrix is multiplied to it, it will stay the same. So parang
Yeah.
how
Pwede ganun. May isa-solve ka na ano na para mangyari, so halimbawa you have ayun, A sub 1 1, A sub 1 2 dot dot dot, tapos actually I suppose you just do 1 1 and then 0. Parang maybe you don't even have to solve for it kasi after all in the theorem we're already making a claim that A sub I sub n is equal to A. So all you really got to do is on the left side multiply A and then times I sub n. So kumbaga, just carry out this multiplication here. Pero actually, pwedeng i-argue na, well, kasi ito, pag i-multiply here, the only thing that's left is A sub 1 1. So in the end, on the right side, you end up writing all the entries of matrix A. So pwedeng ganon. Okay. Anyway, here, C sub ij is the sum, and then, kasi A sub I k and I sub k j. As k runs from 1 all the way to m. Okay, kasi A is m by m. So itong second index ng A, which is k, is what's gonna run from 1 all the way to m. Okay, but for the identity matrix, I sub, wait, okay, maybe it's not, let me use a different letter because we've been using small I for the I throw. Okay, so ano gamitin natin? Let's say P sub ij.
napapumili po kayo mga mga
Ano?
obscure na mga Babylonian letters na mga ano po para
Ano gusto mo?
Ayun, ano?
Delta or epsilon, Greek letter?
yung mga ano, di ba yung mga ancient obscure letters na mga ancient obscure languages.
Okay. Next time, dapat prepared ka sa mga obscure letters. Okay. Ito, theta na lang. Theta. what characterizes the identity matrix is that you only have one in the main diagonal. So theta sub ij is equal to 1 if I is equal to j. Okay. Sorry, if I is equal to j. Because a diagonal entry is an entry where the row number and and column number are the same. So, like for example, the second diagonal entry is if row number 2 and column number 2. On the other hand, if A is not equal to J, then that's going to be 0. So, okay, theta. So from what we pointed out, this is going to be 1 if and only if K is equal to J.
Wow.
Otherwise, if K and J are distinct, it's going to be 0, which means that when you carry out the summation, all the other terms would vanish and become 0. The only thing that's going to survive is when K is equal to J. So we end up with A sub I J, and then theta sub J J, and then everything else is going to be 0. But then this is going to be 1, and there you go. A sub ij times 1. Therefore, the matrix C is equal to A. Or in other words, A I sub n is indeed equal to the matrix A.
Wow, okay, na-prove na mo.
So, I mean, it's so easy to take it for granted based on how matrix multiplication is defined. All that we did here is, kumbaga, if we're going to write it down formally, how is it going to look like? Okay. Ngayon, let's formally give a definition of a non-singular matrix. N by N matrix A is called non-singular or invertible if there exists an N by N matrix B such that AB equals BA equals I sub N. This matrix B is called an inverse of the matrix A. Nung matrix I sub n, if we look at the previous theorem, I sub n or I sub m is parallel to the number 1 in the set of real numbers. Because we now have, if you take any number, multiply it by 1, the result will be the original number. 1 times 7, the same as 7 times 1. The output is going to be the same starting number 7. So now numbers have reciprocals. The reciprocal of 7 is 1/7. The reciprocal of negative 1/2 is negative 2. By reciprocal, we mean a number which when multiplied to the starting number gives us 1. So in this theorem, given the matrix A, you could almost think of the matrix B as the reciprocal of A. And vice versa, if we take the point of view of the matrix B, then the matrix A is a reciprocal of the matrix B. Okay. Do all numbers have reciprocals?
Pat.
All real numbers.
Zero does not have a reciprocal.
0 is the only real number that doesn't have a reciprocal.
Wow,
So,
okay.
will all matrices have, will all square matrices have a reciprocal? an inverse.
Yun po
Or
siguro.
hindi, no? So for example, if you take A to be the zero matrix, whatever matrix B you multiply to it, it's never gonna be an
Ah,
identity matrix.
so meron po trivial kagad na 0 po will never have a reciprocal M.
Yeah, or there definitely is a matrix which is a square matrix that's non-singular and it would be any square zero matrix. It's always non-singular. 2 by
Okay.
2 zero matrix, 4 by 4 zero matrix. Well, okay, a 4 by 7 zero matrix will have no inverse, but that's because we are defining inverses only for square matrices. So kumbaga, in the first place, if we're working with a 4 by 7 matrix, the idea of an inverse that doesn't work or is not applicable in that situation. Okay. But well, the number 2 has only one reciprocal, 1/2. The number -7 has only one reciprocal, -1/7. So for real numbers, if there is a reciprocal, it's unique. And I suppose in the computational linear algebra you've seen, if a matrix has an inverse, I suppose we sort of assumed that it's unique. But if you go by, hold on, sorry, this should not be a theorem, but rather a definition.
Amo.
Diba? Definition. We're defining what it means for a squared matrix A to be non-singular. It's when there exists. But how do you know this inverse is unique?
Ah. So
Diba?
so parang may must prove na there's only one inverse for all.
So that then we can refer to this as the inverse of A. So far, sinulat ko dun, no? This matrix B is called an inverse. The inverse of a square matrix, if it exists, is unique. Okay. So prove natin. So let A be a square matrix and suppose we have two candidates for its inverse. Given n by n matrix A, suppose B and C are n by n matrices such that B and C are both inverses of A. In other words, AB equals BA equals I sub n, and AC equals CA equals I sub n. In other words, B and C both satisfy the definition of an inverse. So what are we going to do in this theorem? We're going to show that, oh, it must be true that B and C are one and the same matrix. One and the same. So
Ah, okay.
kumbaga, di ba?
Kumbaga para to prove there's only one thing, there's only one result. Prove that the many results are just the same.
Yeah, they're gonna be the same. So kumbaga, wala ka talagang makikita na na kakaiba kasi as soon as you think you have what might be a different candidate, boom, you show that, oh, you know what? Ito din yun eh, pareho lang yun eh. Okay, so we're
Opo.
gonna show that B must be equal to C. Okay. Hala, paano nga ba yun? Okay. Hindi, kaya. Ganito papaglalaroan. So, from, okay, here. I'm going to do the following. BA C equals I sub M C, right?
No po.
But then I sub M C is what?
C.
C.
Bro. Okay. Sige po.
Next. Okay. I'm gonna take ito, pinagsama. AC equals I sub M. I'm going to pre-multiply, meaning multiply from the left by B. B multiplied to AC equals B I sub M. But what is B I sub M?
B.
B. So look here. We are saying that matrix B is equal to this. And matrix B,
Associative property mo.
yes, associative property. Okay. Therefore, gets na B, which is B pre-multiplied to AC. But then this is no different from BA multiplied to C. But the latter is the matrix C.
Wow. Nice.
Wala. All right. So ibig sabihin, nung inverse, it's unique. Okay. So if A has an inverse, thus, okay, if A has an inverse, okay, we will denote this unique inverse by using the notation A and then superscript -1. Okay? Parang ano, nung A inverse, A superscript -1, well-defined na siya eh. Kasi it's not like, which of the many possible candidates will this be referring to? Kasi we won't even have that question anymore about there being possibly many candidates because we have just justified that if there is an inverse, isa lang yun. And that single unique inverse, that's what we're going to denote by A raised to -1. Okay. In fact, ang sinusubukan kong tandaan, what if ano eh, may way to prove eh, na kunwari AB is equal to I sub M, it can be shown that BA is equal to I sub M. Okay? Kasi dito sa definition, inassume natin that given the matrix A, then this matrix B is such that AB is equal to BA equals I sub M. Okay? So kumbaga, if you look here, okay, so we could almost call B as follows. B is the right inverse of A. And here, B is the left inverse of A. Okay? Pero how do we know that if AB is equal to I sub M, is it possible that BA is not I sub M? Parang posible ba yun? Again, nung what I'm claiming is, suppose A and B are both n by n, and AB happens to be I sub m. Would it follow that BA is also equal to I sub m? Kasi we know that matrix multiplication is not commutative. What if posible pala na BA is not equal to the identity? Or posible nga ba? Or imposible yon? Kasi kung BA will automatically always be I sub m, then it must be possible to prove it. Okay.
Maybe it is
So,
possible po to prove it.
ano yan?
Likely it is possible nga po to prove it.
Oh, it should be possible, no? Okay. Ito. Theorem. Something close to it. Um, if A has parang ano, this goes beyond discussion of the inverse. Okay, so suppose A has a right inverse B, or in other words, AB equals I sub m, and A has a left inverse. Actually, nung na-prove natin ganito, if A has a left inverse B, in other words, BA equals I sub m, and A has a right inverse C, in other words, A multiplied to its right is I sub m, then A is equal to C. Kumbaga, kung ano ang left inverse, right inverse din yon. And ano man ang right inverse, it's also going to be the left inverse. Sorry, of course, I meant to say B is equal to C. Actually, the proof for this is what we have already done above. Kasi after all, ang ginamit lang naman natin dun sa proof is the fact that AC is equal to I sub m.
What
We
if B?
didn't, hindi natin ginamit nung CA eh.
Opo.
So ginamit lang natin, C is our right inverse of A. Okay? And then regarding B, ang ginamit lang natin, BA is equal to I sub m. In other words, B is a left inverse of A. And we were able to show that B is equal to C. So if the inverse of a matrix exists, it is unique. Okay. So I'm sure you've already done a lot of computations involving inverse matrices, right? Finding the inverse of a matrix.
Opo.
Okay. But the methods that you did, ano yun, gumamit ba ng mga RREF? Yun ba nung how did you in general find the inverse of a matrix?
Cross-ordered elimination lang po.
Ayan, so elimination din, di ba? So, of course, there are other methods. So we're gonna go through the theory behind that. Yung mga methods for finding the inverse
Why
that
did it
are
work?
available, why do they work? Okay.
So,
But
sakto-sakto po yung lessons kasi ano po yung lesson yata doon sa EDX, matrix algebra na po siya eh. Bali, tapos na po yung linear algebra 1 po. Natapos na ni Joshua. Bali, 2
okay.
or
So
mag-start.
that's a module number 2 na ano na nang ginagawa doon?
Hindi po module, parang yung course number 2 na po siya.
Which is?
Yung una kasi po, ano ba yung topics sa linear algebra 1?
Basics siya, tsaka yung linear transforms.
Linear transforms pa lang po. Bali, yung matrix algebra sa yung linear algebra course 2 po.
Course 2. So papunta pa lang.
Papunta pa lang po siya.
Okay. But is it okay that we're doing this? Kasi when I teach, I start with ng mga computational muna, like
Mas maganda nga po eh, para mas ma-explain. Kasi iba po yung pag-explain din nila doon sa ano po eh.
Okay.
Sa EDX po, iba po.
Understood. Am I right in assuming that it's more theoretical? It's more computational?
Opo, mas theoretical po siya.
Wait, ano ang mas theoretical nung doon sa EDX or in what I'm doing right now?
Yung ginagawa niya po actually.
Sa akin, theoretical.
Yung tawag doon, the why.
The why.
Nung the why. So I suppose it's okay that parang it's okay to see both. Meron nung practical implementation and meron din nung the why. Okay. So parang in the end, it all builds up to academic and mathematical maturity. Okay. So theorem, at least yung iba dito kasi hindi natin mapuprove lahat. So we'll just maybe prove lang natin nung medyo mabilis. Let A and B be non-singular and by n matrices. Okay. When you add, rather, when you multiply AB, this is also going to be non-singular. And in fact, what's the inverse of AB? Or rather, how can we find the inverse of AB in terms of the inverses of A and B? Do you remember this? What's the inverse of AB?
Mila mo. Inverse of AB. So, yung AB times yung inverse na dapat iko to. Equal to 1. Mila mo.
Okay, actually, I was just checking kasi if you're already familiar with this.
Ano mo? Mila mo. AB. A inverse B. Di yata necessarily.
It's actually, we start with B inverse and then A inverse.
Bakit di po siya A inverse, B inverse?
Okay, kasi ang ginagawa natin, ganito, no? Given the starting matrix AB, gusto natin maghanap ng ano ang pwedeng ilagay doon sa blank so that the result will be the identity matrix. Okay, kasi if you can find what you can place there in the second factor, because this is a proof, let me write it using a different color. Okay, so ito, A, B. So we're trying to look for what we can place there so that the result will be the identity matrix. Okay, and it turns out that if we dump there, ito B inverse A inverse, apparently it's the one that's going to work. Okay, how so? Why is it gonna work? Kasi, look, AB, let's multiply that to B inverse A inverse. Wait, sorry, I said I was gonna use a different color for the proof. Okay. So AB multiplied by B inverse A inverse.
Pwede na pala po
Fortunately,
pwede ba kaya po sa OneNote, di ba po, i-select na po tapos i-click nila po yung color of your choice to change the color.
Oo nga, nalimutan ko medyo. Most of my classes are already on-site. Nalilimutan ko na ng ibang mga things that we could do. But there is one thing I have not forgotten, Joshua.
Oh no, alam mo, alam mo, nag-connect na po yung
Okay. I promise you, I will never forget it for your sanity. Okay. So, buti na lang associative. So, B inverse, A inverse. So, if you're asking, bakit hindi A inverse, B inverse? Well, actually, we need B inverse first kasi iyon nung maitatabi natin sa B. Because then, once you
kaya
get
po.
them together, you have the identity.
Pag ganun. So, siya muna yung nakataas mo.
Oo, right. Parang nung point. Okay. So ito, pag ituloy natin, so it's gonna be A I sub n A inverse, tapos let's say ano ba nung ginagawa, we could do that first, but then that's gonna be A inverse. So in the end, it's gonna be I sub n. And then the thing is, because diba, we talked about how the inverse is unique. So as soon as you found a candidate, yun na yun, wala nang iba. And here we have identified a candidate, which means there is nobody else. So the inverse is B inverse A inverse. Parang nung analogy na nabasa ko about this is ganito. Imagine that A is, okay, put on socks. Followed by B, put on your shoes. And then when you take the inverse, you are undoing it. Now, naturally, we put on our socks first before putting on our shoes. So that's why here we have AB. But then if you want to reverse it, ano unang tatanggalin? Socks or shoes?
Choose one.
Shoes. So, ayun, we start with B inverse.
Iniisip ko kasi po yung parang sira-ulo na version.
Sabi na nga ba eh, mga ano iniisip natin, no, Joshua, na, okay, no, I want to go against that. Okay, I'm gonna start a movement where people are gonna remove their shoes first, their socks first before their shoes.
Ano po,
Okay.
gagawin na po talagang, igagano na po yung katawag doon, puputol-putol na po para talagang ma-extract.
Yeah, okay, kasi no, I don't like B inverse, A inverse. Okay.
Okay.
Okay. And number two, well, if A is non-singular, A inverse itself is also going to be non-singular. So in this case, what is the inverse of A inverse?
A po.
A, all right? And this is almost automatic. Because if you look at A inverse, that's going to be the identity. So parang from the point of view of A, the right inverse of A is A inverse, where the right inverse is also the left inverse. And then if you look here, this left side, from the point of view of A inverse, its left inverse is A. But, well, that left inverse is also the right inverse, which is the inverse. Okay. So, and then number three, the transpose is also non-singular.
Wow.
And what do you think is the inverse of the transpose matrix?
The transpose of the inverse po.
Yeah, the transpose of the inverse. Okay, that's because, well, um, well, if you start from the fact that A times A inverse is the identity, when you take the transpose of the left, you should also take the transpose on the right side. Okay. But the transpose of the identity is itself. What do you call those matrices whose inverses are themselves? Have you encountered that definition?
Matrices are themselves. Yung
Their transpose is themselves.
Oh, yes. Symmetric ba?
Yes, symmetric matrices. So I sub n is a symmetric matrix. Okay. But recall too that if you have, let's say, A, B, and you take take the transpose, ano yan? Actually, I think we just wrote it above. Diba B transpose, A transpose. So here we're gonna get A inverse transpose A transpose. So what we see here is that if you take the point of view of A transpose, you could pre-multiply it by this particular matrix in order for the product to be the identity. So therefore, what I underlined here, the transpose of A inverse, this is the inverse of A transpose. So therefore, here, the inverse of A transpose is what was underlined, transpose of A inverse. Okay. And then corollary, if A1, A2, all the way to A sub R are n by n non-singular matrices. So this time, we're going to look at multiplying not just two non-singular matrices of the same size, but multiple, let's say there are R of them, then the product A1, A2, dot, 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 A sub R is also a non-singular matrix. And what is the inverse of this product in terms of the inverses of the individual factors? How do you
Mm,
think can we write it?
ah, 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 ah. Yung papabaliktad po, parang
Uh-huh.
ER na
AR inverse,
A
right?
blah blah blah, ER minus 1 inverse until A1 inverse.
All right, until A1 inverse. Okay, so this is something that can be argued using statement number one above. Okay. Well, some remarks. If A and B, okay, remarks. If A and B are non-singular, does that imply A plus B is also non-singular? Or can A plus B possibly be singular? What do you think?
Wait lang po. So, kung ano, mga simpleng example,
Yeah.
singular na simple example, 1, 1, 1, 1, 0, 0, 1, 1. Okay, so kung gano'n, dahil plus something, siguro, pwede kaya po. I think so. Meron kaya po ma-add. Ano? Kung let's say po maging yung last row maging 0, 0, 0.
Mm-hmm. Yeah. Then A plus B is not necessarily singular. Okay. Oh, let me add here number 4. Okay. So A is non-singular if you multiply the matrix A by some number C. Have you encountered scalar multiplication? Let's say C is equal to the number 2, then CA or 2A means you take all the entries of matrix A and multiply each one of them by 2.
Ano?
Okay. This is non-singular if C is not equal to 0. And what do you think is the inverse of CA?
Inverse of CA. CA inverse.
C times A inverse?
Maybe it's A inverse over C.
Yeah, over C. So 1 over C. Okay. Because if you take CA, we realize that we must multiply it with 1 over C times A inverse in order for the product to be the identity. Kasi di ba if you have a scalar multiple, you can factor it out of all the terms of a matrix and then just multiply the scalars on one side. C times 1 over C and then A inverse. Okay, so we have two groups here, but no C times 1 over C is just ordinary uh, multiplication of a non-zero number by its reciprocal. And then in the second group, it's matrix multiplication, A times A inverse. So you have the scalar 1 multiplied to all the entries of the identity matrix, which is just the identity matrix. So ayun, we have a candidate for the inverse of C times A. Or observe that it is useful here that C is non-zero, allowing us to take the reciprocal 1 over C. What would happen if C was equal to 0? Would the matrix be non-singular or singular?
Singular, kasi may 0 po lahat.
Yeah, because then it would be the zero matrix, and the zero matrix is a singular matrix. Okay, But ito going back to A plus B is not necessarily singular. You can take halimbawa, this is because if B happens to be the negative of A, and if A is non-singular, then multiplying it by a constant like -1 given as matrix B, it would still be a non-singular matrix. So if B is equal to -A, then and A is singular, non-singular rather, so B is not singular, then if you take A plus B, this would be the zero matrix, which is singular. It has no inverse. But of course, posible rin naman that A plus B is singular. If B is equal to A, then A plus B will simply be double the matrix A, which is non-singular. So when it comes to the sum of two non-singular matrices, the sum can be singular or non-singular. Now, what is the implication as well? What if we have the following? If A is non-singular, and suppose that AB is equal to AC. Now, I pointed out in general that actually it was somewhere here in one of the remarks. Number 3, even if AB is equal to AC, it doesn't mean B and C are equal. They could very well be unequal matrices. However, suppose we add this restriction on A, that it be non-singular. What do you think will that imply about the matrices B and C?
Mm-hmm.
Mangyayari kasi, well, we were thinking of cancellation. When you have 2x equals 6, when we cancel 2, what we're doing is we are multiplying by 1/2.
So multiply both sides po by the inverse of A.
So ang casual sa atin, from 2x equals 6, we write down x equals 3. But if we recall what exactly led to that, it was because, well, we canceled. But let's not forget what we're really doing when we cancel, which is we're multiplying by the reciprocal. This time, meron ng reciprocal ang A, di ba? So that's what you're suggesting, right? Pre-multiply by A inverse, which means that on the left side, A inverse AB is equal to B, and on the right side, it's equal to C. So now
Wow.
you can do the cancellation because A is non-singular. Okay. Theorem. If A is non-singular, what do you think is true about the system of equations AX equals B? The linear system of equations AX equals B. We talked about how there are 3 possible states last time. This could be inconsistent, meaning not having a solution, or it could have a unique solution, or it could have infinitely many solutions. If you start with the equation 2x equals 6, does it have a solution? And is the solution unique? What's the situation with 2x equals 6? Does it have a unique solution?
Yes po.
Yes, and that solution is 3, right? Because we were able to carry out this method, which leads to just one solution 3. So first, it tells us there is a solution, but because we were led to only one possibility, 3, it must be 3. It cannot be anybody else. Therefore, there is a unique solution. But how did we end up with x equal to 3? Because we were able to multiply 2x by 6, both sides, by the reciprocal 1/2. Because 2 has a reciprocal. If you look at the equation, 0x equals 0, how many solutions does this have?
Infinite po.
Infinitely many, because whatever we do, we are not led to a specific value of x. Because we cannot divide by 0, because after all, 0, the coefficient on the left, has no reciprocal. Now looking at ax equal to b, where the matrix of coefficients A happens to be non-singular. It has an inverse. In a way, it has a reciprocal. What do you then think is the nature of this linear system? Inconsistent, or consistent with unique solution, or consistent with infinitely many solutions?
Mm. Ah, baka ano mo, consistent with nawila mo. So kung like infinite solutions pa siguro.
Ano yan? Sorry, what do you think?
Infinite solutions.
Infinitely many solutions? Pero ganito. Starting with, let's start with ax equals b. Because a is non-singular, there is an inverse. A inverse exists. What would happen to the left side if we pre-multiply by A inverse? So mangyayari A inverse A and then X. But what is A inverse A multiplied to X eventually going to be equal to?
Mhm. 1.
Or, well, matrices, not numbers, the
I got
identity. So I sub nx is A inverse B, but I sub nx is just the column vector x. So the column vector consisting of the variables x1, x2, all the way to x sub n. So you can think of arriving at A inverse B as parallel to how we arrived at the unique solution 1/2 times 6. So see what happened here? We were led to only one solution. Therefore, AX equal to B has a unique solution. X equal to A inverse B. Okay. So, what about the corresponding homogeneous system? AX equal to 0. Well, this is just a special case where the column vector B is the 0, is that column of zeros. But done by the same way, the same conclusion should apply. There is a unique solution, which would be A inverse times the column vector of zeros. But when you carry out that multiplication, you have n by n by 1, the result is going to be n by 1, a column vector. What would be the entries of the product?
So dapat ano din po. So column vector yung x.
Mhm.
So dapat yung first row ay yes. So yung first row yung zero. Nga ba yung so yung ano yung row na yun? Yung mamumultiply lang.
Okay. Pero
So,
nung ang homogeneous system, let's recall, consistent ba to lagi or pwedeng walang solution?
Tingnan
Ito,
mo.
let's look at what we wrote about a homogeneous system of solutions. Ito, theorem, you see this?
Consistent.
Consistent. Kasi you always have the trivial solution, x1, x2, x3, all
Zero.
0. You always have a solution, the trivial solution. Okay, so therefore, in a homogeneous linear system, either there is a unique solution or infinitely many solutions. So consistent kasi either infinitely many solutions or unique solution. Pero kasi if the matrix of coefficients A is non-singular, so we said AX equals B, unique lang ang solution niya. So itong homogeneous linear system, special case lang naman to. So therefore, unique lang din ang solution niya, and therefore it must only be the trivial solution. Has only the trivial solution, x equal to 0. Okay. Sige, para hindi ka andugin, magpapahanap ako sa iyo, Joshua, ng matrix inverse. So ito madali lang. So example, okay. Find A inverse if A is the matrix 1, 2, 3, 4. And sige, Joshua. And then just give me the answer. So there are going to be 4 entries. And then use this to solve the following the system of equations: x plus 2y, and then 3x plus 4y equals, mamaya na ako mag-assign. Just give me first A inverse.
Tingnan mo. Isisend ko lang mo. Loading. Okay, loading. The ball pen. Pen ball. Where is the pencil? Yun. Tingnan mo. Aha. Yun. Nice. Wait. So, ano daw? what's the inverse? So 1, 2, 3, 4. Zero.
Are you writing it directly here? Yon. Okay. Nag-appear na. Eh, kaso nga lang, maybe it has appeared much earlier in your screen than it does with mine.
Okay, may konting lag po.
May lag eh.
Opo.
Do you already have the inverse, Joshua?
Tingnan mo. So,
You're doing row reduction. That's what you're doing. Okay. So yeah, I'll check. 1, 2, 1, 0, 1. Okay, so far so good. And then 0, -1/2. Um, ayun. Okay, -2, 1, 3/2, and -1/2. Correct. Okay, I agree. Okay. So yeah, okay. You found a inverse. Okay. Pero so I understand the algorithm you're employing here, but I guess it stands to a paparang question doon. Bakit nung Gauss-Jordan reduction, why does this work? Why does it lead to the entries of the inverse doon sa right side? Nung 2, 1, 3/2, -1/2. But anyway, it can be verified that when you multiply your A inverse to the matrix A, that we're indeed going to get the identity. Okay?
Opo.
And it takes some time to be faster at finding the inverse. Parang paulit-ulit-ulit lang. Okay. So now, going to the system, kung x plus 2y equals negative 18 and 3x plus 4y equals 14, we could write this as iba 1, 2, 3, 4 multiplied to xy equals negative 18, 14. Okay, so you have ax equals b. But then you can multiply by a inverse on the left, and we will get x equals a inverse b. So yun nung a inverse mo, negative 2, 1, 3 halves, negative 1 half, then multiplied to negative 18, 14. Nung b, what this should give us are the solutions of the system. We have 36.
Oh no, wait lang po. May
Plus
nag-ano po,
14.
tawag nun, nag-ano po yung OneNote, tawag nun yung, dati po diba yung may eraser tapos nun ayaw nang gumana.
Ano na sa'yo?
Wait lang po,
What are
mag-crash
you
na,
trying to erase?
mag-crash na yata po yung OneNote para sa akin.
Okay, maybe kasi sabay tayo eh. Sabay tayo gumagamit. I don't know if that's it. But on my part, I can still write on OneNote. So, okay, negative 18 times 3 halves is negative 27
Yun.
minus 7. So we have 50 and negative 34. So that means the solution of the system, x equals 50 and y equals negative 34. For the sake of efficiency, having the a inverse means that if in case negative 18 and 14 are changed, and because you already have the inverse, then that means ito lang nung papalitan in case negative 18 and 14 are to be replaced. Okay, parang small part lang. Oh, ayun, 50, negative 34. Yes, you're right. Okay. Okay.
Ano, pala po yung nasulat.
Okay, okay. Anyway, pareho tayo ng ng sinusulat. Okay. Now, let's tie it up. Parang marami na tayong characterizations for system of equations. When we had the discussion last time, nung general scenario was the matrix A is M by N. However, because we're talking about the consequences of a matrix being square and it being invertible, therefore, when we want to talk about linear systems and include in the discussion the coefficient matrix A being invertible, so ibig sabihin, A has to be a square matrix, and therefore M and N must be equal to each other. Okay? But then when are we going to have a unique solution? And that's going to happen when the rank of A is equal to N. So ganito nangyayari, no? Let's say you're looking at the system, the linear system, AX equals B. If A is invertible, then we know there is a unique solution, X equals A inverse B. But the only way that fits into the situations here, when is there going to be a unique solution? Only when the rank of A is equal to N. So ibig sabihin, if A has an inverse, then the rank of A must be equal to N. And actually, it also goes vice versa. If the rank of A is equal to N, then A has an inverse. It is non-singular.
Wow.
So sulat natin yan nung line of thought na yun. Theorem. Okay. An N by N matrix A is non-singular if and only if the rank of A equals N. So ibig sabihin, if you reduce it to row echelon form, or you perform Gauss-Jordan reduction, then it means that you're going to get n leading ones. Or kasi in the first place, okay, there are n rows and n columns. Hindi ko pwedeng may leading one dito tapos sa ilalim may leading one, di ba? Kasi if you have that one there, you should be able to eliminate this one above and turn that into a 0. So that means in every column, there's going to be a single one. In every row, there's going to be a single one. Ibig sabihin, when you do Gauss-Jordan reduction, ng mga ones, force sila sa diagonal. So, ibig sabihin, for a non-singular matrix, when you do the usual reduction, Gauss-Jordan reduction, the identity matrix is what should always appear.
Eventually po na parang lahat, they will not, yung one sa mga other place will not survive. Only the
ano yun sabi mo ng mga other, what will not survive?
the other ones po will not survive sa outside.
Matatanggal sila kasi meron kang n leading ones kasi the rank of A is equal to n. Okay. So nung sulat lang natin nung argument natin, kasi if and only if. So nung first part, suppose A is non-singular. Then for any B, the linear system AX equals B has a unique solution. But then we argued, ibig sabihin, ng rank of A equals N. Actually, tingnan ko nga ulit kung sinulat natin. Ayun. Okay. So rank of A equals rank of A sharp, the system is consistent. But if rank of A is strictly less than N, infinitely many solutions. No second bullet point. First bullet point, truly the rank of A must be N. This means the rank of A is equal to N. Now, because this is if and only if, then that means there is that other implication. Suppose naman, baligtad, suppose you start with the assumption the rank of A is equal to N. So we're going to show that A is non-singular. But how are we going to show that A is non-singular? By trying to come up with a candidate, what must be multiplied to A so that the result will be the identity matrix. Okay, so what we're going to do to show that A is non-singular, we are going to construct how the inverse is supposed to look like. And then if you have an inverse, ayun na, di ibig sabihin A is non-singular kasi meron tayong inverse na nakuha eh. Okay. Suppose the rank of A is equal to M. Okay. Let me write down here kasi I'll be using notation I sub n. You have 1, 0, 0, and all zeros. Tapos 0, 1, 0, and all zeros. And then 0, 0, 1, and then 0 all the way until the very last column, 0, 0, all the way down to 0 just before the very last. The lowest entry is 1. Okay. I'm going to call this column vector E sub 1. This column vector E sub 2. This would be E sub 3. Ano to ngayon? Anong name ibibigay natin dito?
Ano po yung ano?
Nung last column. What do you think is its name?
Ano ba? Wait lang mo. So, rank is N, no? N square naman po siya. So, E sub N.
Hindi. Jobert ang pangalan niya. Marunong ka. Naisip ang pangalan niya. Jobert ang pangalan niya. Okay. Okay. Sige na nga. But it goes by the nickname E sub M. Okay. I'm gonna use that notation ng mga E sub M. Okay. So yun na to. Okay. Rank A is equal to M. So ibig sabihin, ito no, we can use this. If rank of A is equal to N, that means the linear system AX equal to B will have a unique solution. Pero in fact, pwede natin palitan ng B eh. Pwedeng B is a particular column vector and then you will have a unique solution. If you replace B by a different column vector, then you will have another unique solution. So what I'm going to do is, I'm going to use as the column vector B, itong E1, E2, E3, until Jobert. Okay. Let X1 be the unique solution of AX equals E1. Actually, para siguro hindi nakakalito kasi nung X, actually, we could think of X as ano eh, X1, X2, dot, 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 X sub N. Okay, nung solution ng system. So, for AX equals E1, ito, let X equals Y sub 1. So, ibig sabihin, nung Y sub 1, it's a column vector. So, ayan, column vector siya. But I'm denoting the solution by Y sub 1 to show that this is what's going to correspond when we use E sub 1 on the right side. And then let X equal to Y sub 2 be the unique solution of AX equals E sub 2. A has rank N. So itong two linear systems, unique solution. Until finally, AX equals E sub N. So that's going to have a unique solution, Y sub N. Okay. Finally, okay, nung Y sub 1, column vector siya. Y sub 2, column vector din. Until Y sub N, column vector then. What we're going to do now is finally let Y be the following matrix. The first column niya would be from Y sub 1. Nung nakuha natin na solution from the first linear system, yun ang ilagay natin sa first column. And then the second column, what we got from the second system, Y sub 2. Until we get to inserting the last column, Y sub N, taken from the last system. Okay, and then ang claim natin is that ito nung inverse ng A. Okay, ito nung inverse ng A. Paano? Let's have a look. A, Y. Okay, so you have them A. And then, nung Y, you have, okay, itong first column, Y sub 1. From first column, y sub 2, until the very last column, y sub n. Okay. In fact, I think it might help tapos CA. So as usual, A sub ij. So A sub 1, 1, row 1, A sub 1, 2, hanggang A sub 1n. Tapos ito row 2, A sub 2, 1, A sub 2, 2, until A sub 2n. Last row, A sub row n. A sub n1, A sub n2, hanggang A sub nn. So tingnan natin, ano nung lalabas na product? Okay. You have an n by n matrix, n by n matrix. So the result is going to be an n by n matrix. Okay. Okay. Pero mangyayari dito, actually, itong buong na to, this is just A. Okay. Turns out maybe hindi ko na siya kailangan i-spell out. But nangyayari when you multiply A to y1, pero kasi remember that ano nung y1? Y1 is the solution of this system. So ibig sabihin, A y1 equals E1. Similarly, A y2 equals E2 until A yn equals E sub n. So mangyayari, nung makukuha natin matrix A multiplied to the column y1, so that will be A y1. Tapos matrix A multiplied to y2, that will be A y2 until A multiplied to the column y sub n. Okay. Pero nung A y1, that's E1. A y2, E2. A yn, E sub n. Ibig sabihin, we're going to end up with a matrix whose first column is E1, and that's 1, 0, 0, all the way to 0. The second column is E2, and that's 0, 1, 0, all the way down. The last column is E sub n, so 0, 0, 0, all the way down to 1, but this is nothing else but the identity matrix.
Ano po, breaking it apart and putting it back together.
Yeah, precisely. So ibig sabihin, therefore, Y A has Y as its inverse,
Nice.
i.e., A is non-singular. Okay. I know you have already seen determinants, right?
Opo.
Determinants. Now, you might remember, what's the determinant of a non-singular matrix?
It's na, basta yung non-singular po is non-zero. Pero pag singular po siya, 0.
So actually, parang meron tayong madaming mga criteria for equivalent characterizations for non-singularity of a matrix. So dapat, if you have a squared matrix, it's only going to be non-singular if AX equals B has a unique solution, or equivalently, the rank of A equals N, or equivalently, its determinant is non-zero. So lahat yon, ibig sabihin, the matrix A is non-singular.
Opo.
Okay. Tapos, so, ibig sabihin, remark. Okay. So we're given the square matrix n by n matrix A. Okay. A is non-singular if and only if, so we know that the rank of A equals n. If and only if the linear system ax equals b has a unique solution. If and only if I haven't used this abbreviation, but you're familiar with row reduced echelon form.
Opo.
Row reduced echelon form of A is I sub n. Kasi in the row reduced echelon form, that's where you're gonna see the leading ones. But the leading ones, the number of leading ones is the rank of A. And there are n leading ones. So ibig sabihin, parang imposible na magkakaroon ka ng row of zeros. Okay, so ibig sabihin you have an n by n matrix, tapos there are n leading ones. So nung leading ones, sila nung dapat mag-fill up ng diagonal. So ibig sabihin, you get the identity matrix. Okay. Ano pa ba ng mga weird questions na or interesting questions, or depends how you look at it. So ganito, if you have A and B non-singular, then it follows that AB, the product, is non-singular. Tama, di ba?
Opo.
What if you start with AB non-singular? Does it follow kaya that A and B are non-singular? What do you think?
Wait lang po. Kung si non-singular yun, ibig sabihin, there it's equal to B inverse. Yung inverse na B inverse times A inverse. Siguro, both of them should be non-singular.
Oh, siguro no, pero you're right a priori, hindi natin siya ma-conclude kaagad. But fortunately, the answer is yes. Okay? One way to argue is the determinant of AB is non-zero, 'di ba? Kasi AB is non-singular eh. But then ano ibig sabihin nito? The determinant of AB, assuming A and B are square, no? Hindi nung like 4 by 7 tapos 7 by 4. Assume natin A and B are both square. So 4 by 4 and
They
4
won't
by
have
4.
inverses po. They cannot have inverses, yung mga non-square.
Oo, oo. Pero so kunwari square si A and also si B. The determinant of AB is equal to the product of,
The determinants of A and B
all
po.
right, the determinant of A tapos the determinant of B. Pero this product is not equal to 0.
So both can be zero either po. Yung A and
Oo. So, ibig sabihin, A and B are both non-singular. So, this
Wow.
can be argued in terms of determinants. Pero, syempre, wala pa tayo sa determinants. So, how can we argue kaya that if A and B are non-singular, if A and B are both n by n, and AB is non-singular, then A and B are both non-singular. Okay, so yun ang goal natin. Paano natin papakita na diba, kahit si A lang muna, kasi we believe, if we can show that A is non-singular, then we can maybe just adjust the solution to show that B is also non-singular. So, nung isa lang muna, nung A. Pero so far, what we have done is, if we can find a candidate for the inverse and show that this candidate works, edi yun na yun, may inverse na tayo. So kailangan lang natin maka-figure out, is there anything we can post-multiply to A so the result is I sub n? Or equivalently, is there something that we can pre-multiply to it so that the result is I sub n? Any one of these, kung mahanapan natin ng candidate, yun na. Okay?
Opo.
A and B, sorry, AB is non-singular, no? So, proof. So, AB, so, so, halimbawa, you start with AB inverse. So, parang we gotta be careful. I know we have the theorem where we can write this as B inverse, A inverse. Pero kasi assumption dito that B inverse exists and A inverse exists. Kasi after all, if you go back to the theorem above, ito nung related theorem, ito nung theorem statement number 1, ang starting point nito, nung factors A and B, non-singular. So therefore, we have no qualms writing down B inverse, A inverse, because we know B inverse and A inverse exist. Kasi we're starting with the assumption A and B are non-singular. But this time, well, we don't know that. So, we can't write down this product on the right side kasi we don't know that B inverse and A inverse exist.
Oh no.
Okay? So ngayon, I'm trying to reconstruct. Paano ba nung usual na ginagawa
Ano po?
dito?
Tawag mo doon complete disaster.
Yes. Okay, kasalanan ito ni Jobert. How about let's see what would happen if we multiply this to okay, B. All right, got it. Ito. AB inverse. This exists, right?
Ano mo?
Okay. Thus, if we multiply by B, this exists as well, yes?
Ano mo?
Okay, so kumbaga, nung sinusulat natin, sure tayo, it exists. It can be computed. Let's see B equal to that. What would happen if we multiply A and C like this? What would we get?
So, AC is equal to, so AB times AB. Okay. So
Gets na?
that's, so by associative,
Associativity.
associativity. So maging AB times AB inverse. So that's equals identity.
So yun, AC equals I sub n. So what does this mean? There is something we can multiply to A, leading to a product of the inverse of the identity matrix. So A is non-singular. Ayun. Okay. A is non-singular. Tapos, we want to do something. Sige nga, show natin na na B is non-singular. So, I guess,
The other way around lang po.
pero, wait, if A is non-singular, then we could do something like what we did here, create a matrix D, pero hindi na necessary kasi A is non-singular, di ba? Thus, A inverse is non-singular. But what happens when you multiply non-singular matrices? Is the product also non-singular?
Not necessarily nga po.
Hindi, when you multiply non-singular times a non-singular matrix.
Si non-singular mo.
Non-singular, sure tayo, di ba? If kasi actually ito yun nung theorem dito sa taas. Here, number 1. A non-singular, B non-singular, when you multiply, the result is non-singular. Okay? It's actually what we can apply here. Kasi, look, A is non-singular, di ba? And then, AB is not also non-singular. And then, would you like to continue?
Ayan. So, since gano'n nga po. So, times yung isa naman, B. Ano siya? So, A inverse times A times B by associativity nga po. So,
Mhm.
therefore, 1 times B equals B.
So this product is equal to B, right?
Opo.
And B has been expressed as the product of non-singular matrices.
Oh, no. Okay. So,
Gets
definitely.
na? Therefore, the product is, which is
Non-singular.
B, is non-singular.
Wow. Okay, nice.
Ang dami ng thus. Thus, and then thus. Okay.
Gamitin na naman po naman. Therefore, tapos ang mga...
Therefore, consequently. Therefore,
As a result, ito po, ganun, mga
the product B, which is A inverse of AB, is also non-singular. All right. So yun, ibig sabihin, if you have a product which is non-singular and it's factorable into square matrices, then those factors should also be non-singular. Was some familiar it's already 4:57 na pala. So ano, maybe this is enough for now. So we can meet siguro next week. We can try next week.
diba?
Okay? All right. Sige. Okay.
Thank you
po.
Hey, and
Sir,
Joshua, enjoy the rest of the week. Bye.
Bye-bye
thank you
po.
po. Bye-bye po.
All right.